Hello, fifth grade math students. This is our video looking at lesson 13.1, which is called Classifying Triangles. If you don't already have your textbook out, please open it up to page 186 and you can follow along with me. Some of my triangles will be a little bit different than the ones in your textbook, but for our purposes, this should be able, you can follow along with this. If you do not already have it, you are certainly going to be using a ruler for this lesson and also for the brief homework pages after this. So make sure that you have that. You may also have a protractor. You probably won't need it, but if you'd like to have it handy, then you may. So we're going to be looking at classifying triangles, which basically means identifying what kind of triangle each of these are. And there's a few different ways to classify a triangle. The first way we're going to look at is by examining the different sides of it. How many sides are there to a triangle? That's something you should know from before. There's 3 different sides. And depending on the title we give a triangle, we can learn something about the length of the sides. The first one is called an equilateral triangle. Now, what word do you hear in equilateral? It's not spelled like equal, but you can hear the word equal when I say equilateral. And so what that means is that in an equilateral triangle, all 3 sides are equal to each other. And if I got my ruler, I can measure these. I used inches. Side AB is 1.5 inches. CB is 1.5 inches. And so is AC. Because they're all the same length, it is an equilateral. Now the way you show that something is equal length is you put a little dash on all the sides that are the same measure. So AB is equal to CB is equal to AC. So I put 1 dash on each of those because they are all equal lengths. So that's our first way to identify based off sides. The second type of triangle is called an isosceles. And as you look at that triangle, what would you guess an isosceles triangle has? At first glance, it looks like FD and DE are pretty similarly length, doesn't it? Let's measure them. You always got to measure to make sure. FD is 1.5 inches. DE is 1.5 inches. And FE is a little over 2.5 inches. So these 2 sides are equal. So I'm going to do the dash mark on each of those. But FE is a different length, so I'm not going to put the dash mark there. So only 2 sides are equal to each other in an isosceles triangle, one less than an equilateral. And any guess about our last kind of triangle? We call that a scalene, which isn't the most obvious thing on how to pronounce. I'll say it again. Scalene. In a scalene triangle, they all have different sides. It looks kind of like GH and IH are the same length, doesn't it? But if I measure it, GH is barely over 2 inches and IH is closer to 2.5. So they're close, but not exact. And close doesn't cut it when we're looking for things to be equal. So this is a scalene, which means all 3 sides are different. So I don't need to put a tick mark on any of them because there's no sides that are the same. So briefly again, by identifying with sides, you say they're equilateral. All 3 sides are equal. Isosceles, 2 sides are equal. Or scalene, all 3 sides are different. Any guesses the other thing we use to identify a triangle? If you were thinking angles, you would have been correct. We can use the angles inside of a triangle to say what kind of triangle it is. Any guesses what this one would be called? Triangle PRQ. You may see that little square there, and what does that square mean? That means it's a right angle. So we are going to call this a right triangle because there's a right angle. You don't need to say right angle triangle. You can get rid of the word angle in between and just say right triangle. And then what that tells the reader is immediately that this triangle has a right angle in it. Can you think of a triangle that would have 2 right angles? Running into a problem, right? If it's a triangle, it has to have only 3 sides. But if it has 2 right angles, these 2 sides are never going to be able to meet. They're actually parallel lines. You can fool around with this on your own, but it is impossible to draw a triangle with more than 1 right angle. So by calling it a right triangle, I automatically know that there is one right angle. Now let's look at this one. There's also a right angle. What else do you maybe notice about this triangle? Look at the length of AB, 1, 2, 3, 4, 5, 6 squares. And BC, 1, 2, 3, 4, 5, 6. What kind of triangle has two sides that are equal? Well, if you remember from what I just told you, that is an isosceles triangle. Make sure I spelled that right. Yes. Isosceles right triangle. So by calling it isosceles and right, I immediately know quite a bit about this triangle. I know two sides are equal and that one angle is going to be a right angle. So you can use both the isosceles, equilateral, and scalene title as well as the right label to let me know what kind of triangle it is. Let's look at another kind of angle though. What would we call this angle? Acute, right, or obtuse? If you're thinking obtuse, you'd be correct. Remember, obtuse is anything larger than 90 degrees, and this definitely passes that right angle mark. What we call a triangle that has an obtuse angle is an obtuse triangle. Now let's ask that same question we asked with right angle. Can you think of a triangle that has two obtuse angles? Those are actually even farther apart than the right angle, right? If it's with three sides and has two obtuse angles, these poor ends are never going to meet. I'd encourage you to fool around a little bit with yourself and try and make a triangle that has two obtuse angles, and you'll find out that's impossible. So when I hear obtuse triangle, I automatically know that only one angle is obtuse, because that's as many as possible. Well, if we have a right triangle and an obtuse triangle, any guesses about what we're going to call this triangle? If you were thinking acute, you would be correct. Notice that all three of those angles are acute. And you may be thinking to yourself, well, the obtuse triangle also has two acute angles. And actually, so do these right triangles up here. Every triangle has at least two acute angles. It has to, otherwise the sides wouldn't meet. But the right triangle and the obtuse triangle uniquely also have a right angle or an obtuse angle, in addition to the two acute angles that every triangle has to have. So acute angles are unique because all three are acute. Obtuse are unique because only two are acute. The other is obtuse. And then the right triangle is unique because two are acute and one is right. Okay, and like before, you can actually use multiple labels for a triangle. So if I look at these different lengths, they look pretty equilateral, right? You can have an equilateral acute triangle. Now I should use my ruler to check that to make sure these are actually the same length and they don't just look like it. But if they did prove to be the same length, it would be an equilateral acute triangle. All right, so those are our two ways of identifying a triangle. By looking at the angles, are any of the angles acute, obtuse, or right? And the other way is by looking at the sides and identifying, are they all equal, are just two equal, or are none of them equal? And the scalene, isosceles, and equilateral. All right, that's actually all that we have to learn today. There's pages in your workbook to look through, but it's actually just identifying 8 different triangles. So it's quite quick. So if you can turn to your workbook, it's on pages 121 to 122. Take a few minutes to look at those and identify those different types of triangles. You are going to need to have at least a ruler. You may want to bring a protractor too. You may not need it. That's up to you. But after you have done those 8 identifications on your own, please watch my video, which will be quick, going through those same problems to make sure that you understood these concepts. Thank you.